Okay, so E, we got the phi of P1 implying P2, and we got psi of the negation of P2 implying the negation of P1. So truth table for P1 and P2. It's an obvious thing to have in your brain, but you know, just to avoid mistakes. It's very easy to make mistakes, and this is foolproof. It's foolproofing. So it's not saying that you're a fool. It's saying that you're not a fool. It's saying that you're making it very difficult to make any sort of mistake, and that is very good. That's very good way of thinking. Even if we're doing repetitive, long, simple steps all the time, we just this is yeah. And eventually coming up with better strategies is natural. So so we have the table. Now let's do the so P1 implying P2 0 0 0 1 1 0. Ah, this is terribly written again. Sorry. P2 0 0 0 1 1 0 1 1, and we got the negation of P2 implicating the negation of P1. So we got the opposite here, so 0 0 1 0 0 1 and 1 1. Now let's see, we got so this one returns 1, this returns 1, this returns 0, and this returns 1. This we have to do the negatives first, so negations. So 1 0 1 0 and 1 1 0 0. And now 1 implies 1 is 1, 0 implies 1 is 1, 1 implies 0 is 0, and 0 implies 0 is 1. And so we get 1 1 0 1 in this sequence, and the phi sequence. And we get on the psi sequence we get, so here we looked at these values, here we gotta look at these values, 1 1 0 1, and so we get the same values. So we so I put some space here. So Therefore, uh, the formulas are they are in terms of valuation, they are equivalent. So this is you're never gonna be. I mean, I can't state this, but if you have cool teachers, they won't penalize you. They won't take credits from extra deductions that you make, even if they're not as particularly asked in the question. So this part is the only one that we want to express that, so that the out the outputs for each formula are the same given the same input simultaneously. Therefore, the formulas are equivalent. So, and the rest is just sugarcoating it a little bit, to be honest. And we're not doing it on purpose, it's merely intellectual exercise. Okay, so coming to F. We got P1. Yeah. And we have psi, which is P1. So the simplicity hurts on this one. So let's begin with the P1 table. P1, P2. Sorry. So 0, 1, so 0, 0, 0, 1, 1, 0, 1, 1. That's for 5. Well, that's for both of them. Anyways, so and then we got. It's interesting because we can also do. So let's say that we define this table as the truth table for phi with both these variables. If we were to define one for psi, we could also do both variables, which is funny. Because it's irrelevant. P2 does not appear at any time, so we're basically, so in essence, the same table, the major, so the reason why we have this question is that we want to know if really we could phrase it like this. If we have, so P1 can be 1 or 0, P1, but can phi for P1 given 1, can phi return 1, and for P2, well, P2 matters for phi, but it doesn't matter for psi. So if P1 is 0, it matters for psi, but can phi, which depends on P2, can it also provide a 0? So that's the real question. It's pretty simple. Pretty easy on the eyes. So, let's see. The truth tables are here. Oh, I forgot that we're trying to. Okay, I'll just do it down here. Let's close this gap. So let's do psi, phi, sorry. P1 conjunction P1 or P2, and then we got 0, 0, 0. God. Then 0, actually, sorry, yeah, 0, 0, 1, and then 1, 1, 0, and then 1, 1, 1. And finally, for psi, we got either, so we got P1. So this is either 0 or 1. And that's the answer given. So for that one. So this one or the other produces 0, this one or the other produces 1, 1, 1. And then we got the conjunction, which gives 0 here, 0, 1, and finally 1. Now, so by giving, so the ones where we give P1 0, right, we get the value 0. And the ones where we give the value 1 to P1, we get the value 1. So these are logical equivalents, because that's the exact same output. So in psi, so therefore, actually before the conclusion, so what we're saying is that when we have phi, which has two variables, which are P1 and P2, whichever where P2 can be 1 or 0. If we give the same values, so and psi, and then psi, whoops. So given the input for P1 and P2 simultaneously, we get the same output for phi or